Hello. Today we try this question. Insert into a binary search tree. Let me explain the question of it. Suppose there is a tree. First of all, you need to understand what is binary search tree. Binary search tree (BST). BST is nothing but if suppose there is a root at the top and the node of this, and suppose the value of this is x, this is x1, and this is some r should be greater than x, means the smaller elements lies this side and the bigger elements of lies this side. This is the how the binary search tree look like. Here it asks me to, for example, I'll write an example: 10, 8, 9, 7, 11. Suppose this is a binary search tree. If you take 10, the smaller the elements here, whatever the elements will be, that will be smaller than 10, 8, and this side greater than the root elements will be 9 and 7, 11. Okay, you need to suppose the new element some 6 came. You need to insert. How you insert? You will traverse. You will come at root, and for root you ask them, can I should I go left or should I go right side? Left side or right side? How you can say 10 is greater than 6? So you need to go left side. I come to this root. This is as root. And I'll compare 8 greater than 6. And it says, okay, you need to go left side. 7 greater than 6. You need to go left side. But left side of this particular 7 is null. There is no element. So you need to create a node of 6 and you need to insert into this particular node. Uh, so, okay, whatever it returns, you need to insert into this left side of this. So, suppose root, now root is here, right? Root, root left equal to the returned answer. You need to store it in left right. So root left the returned answer. Let me explain. Solve root. Let's create a function solve root and the value which you wanna insert is x. Okay. If this root becomes root becomes, we try to see whether anything here left of 7, right? If root equal to null, there is nothing. What you do? Root equal to new node of the element x, you think, insert it, and you return root. You return the value of this newly created node. Okay, you are returning. So where you are stored it? Root left equal to solve of root left comma x. You wanna store in the root left of this root left here. So what if root val is greater than x, else root right On right side, you go right side and you return root. What is the root here? Root means the top element which you will return here. The pointer to this. Okay, understood? See how you wanna think where I need to store root left. It's a, I'll I'll explain. I'll complete the code and I'll explain. Yeah. Okay. So, okay. Write a function. Node. Okay. You can write here itself. If root becomes null, what does it mean? It means that you can insert at this place. You can insert a new value at this place. It means nothing. You can insert a, a root new new tree node of val, and you need to return this. You need to return this. And if what we need to do, if root if root val if root value is greater than the new element value, what you will do? What you will do is you go left, right, uh, root left, come, there is an error. What is the error? What's the error? Error. You is it not a proper structure of calling it or not? Okay. Yeah, last chat GPT. Correct. Wait for chat GPT. Last chat GPT. Person. Correct the syntax. What's that? Are? Okay, sorry. Okay, I need to return the root, right? Yeah. I didn't wrote the return statement itself. So what's the point? Okay. submitted. I'll explain it once again in my iPad. How can you write the recursion of it? How can you think of writing like this? Just imagine 10, 11, and 8, and here is 9, and here is 7, and here is 6. Okay, you wanna insert, you want to insert 6. No, 6 was not present. You want to insert 6 here. You want to insert 6. How? Okay, let's imagine this in this way. 10 and what's 8, 11, 7, and 9. You are at root. You check the value x. Is it greater than or less than 10? 10 is greater. So the element x should lie on the left side of it. So you want to traverse on the left. Okay. You check the same. It says it should be lies left. You check here. It should be lies on the left. Okay, you come here. But here it is pointing to nothing. Null. It is pointing to null. So you want to create a element 6 and you want to insert here. So it should be in such a way that the recursive function which we are calling should return the created node and it has to store where you called it. So this is the logic of it.